All right, for the third example of antiderivatives, we're given the information that f prime of x is 8x cubed plus 12x plus 3. We're also told that f of 1 is 6. We're being asked to find f of x. Okay, first things first, we need to talk about the anti-power rule. I'm not sure if anybody else calls it the anti-power rule, but that's what I'm going with. The idea being, what would the backwards version of the power rule be? And in this case, it is x n plus 1. So we add 1 to the exponent. That makes sense because in the power rule we subtract 1, and then we're going to divide by that n plus 1. Just a real quick example to verify this. If somebody said, hey, I'm going to give you 6x squared, what would that have been before you took the derivative? If we follow these properties right here, what we're going to do is we're going to add 1 to this exponent, and we're going to give us a 3, and we're going to divide by that 3 right here. And so let's look what that would give us. That would give us 2x to the third. Now I think the best way to analyze this anti-power rule is always, or anything about antiderivatives, is think about differentiating. And if you differentiate this 2x cubed, you'd bring another 3 to get a 6, and you'd subtract 1 from the 3 to get a 2. So again, what we do to do that is we added 1 to the exponent to get what it would have been before you took the derivative, 3, and then we divide by that 3. And so going backwards with that process. So what I'm going to do is do that for each of the terms that I have for f prime of x to find a basis for the general derivative of f of x. Okay, so if f prime of x is 8x cubed, or the first term is, so f of x then would be, I need to make that an x to the fourth, and I need to divide the 8 by 4 to get 2. That feels right. The derivative of that would be 8x cubed. The same thing for the 12x, so I'm going to make that an x squared and divide that 12 by 2 to get a 6. And again, check that with the derivative. And with this constant term, it's pretty easy. The antiderivative of a constant is just throw a variable on there. The important thing is the general derivative, if you remember, is we have to add this unknown constant. There could be any number being added on here as a constant would resulted in that original first derivative. Though this right here, the f of 1 equaling 6, will give us an idea of how to find, will give us enough information to find that c value. So let's do that. So again, if f of 1 equals 6, this function value is going to be 6 when I plug in 1 for my x value. So let's do that. And what we're going to do now is solve for what that c value needs to be. Now this is pretty straightforward, especially with the 1s. We just get 2 plus 6 plus 3 plus c. That gives me 8, 11. So 6 equals 11 plus c. We subtract 11 from both sides, and what we'll get is that c equals -5. So what do we get then? We get that the original function f of x must be 2x to the fourth plus 6x squared plus 3x minus 5. Again, if I differentiate this, I'll end up with f prime of x being this right here. And also, if I plug in a 1 to this function, it will give me out a 6, like I just verified there. And those are the two steps. Step 1, using the antiderivative information. Step 2, finding the original function information to get our original function, which is the antiderivative of the derivative of 2x to the fourth plus 6x squared plus 3x minus 5.